This is the introduction to an exponential function of base 2. So an exponential function looks like this. Y equals some base a raised to some power, some exponent, where our base has to be greater than 0, and it cannot be 1. So we're going to focus on the most popular of the exponential functions. This is called base 2. So y equals 2 raised to the x, and we want to graph it out. So what I have over here is an XY chart with some ordered pairs already found for us, but I want to show you how this chart has been found. So remember, when you evaluate a function, you're looking for the x that you're substituting in. So here's my x values, and I say, let's start with 0. If my x equals 0, 2 to the 0 power equals 1. So there's my 1. The next one, if my x equals 1, I substitute 1 in for x. 2 to the 1 is 2. So there's my 2. Let x equal 2. So 2 squared, 2 times 2 is 4. So there's my 4. Same thing with 3. 2 to the third is 2 times 2 times 2, which is 8. So I'm just going to erase these numbers here. So there's some ordered pairs. Now let's go in the negative direction. I let x equal negative 1. 2 raised to the negative 1 power is the same thing as 1 over 2 to the positive 1 power, or 1/2. Negative 2. 2 to the negative 2 power is 1 over 2 squared, which is 1/4. Negative 3 power. 2 to the negative 3 power is 1 over 2 cubed, which is 1/8. All right, so let me just erase those pieces here. Now let's go and graph it. So how we graph this function is we graph these ordered pairs. Let's move this up a little bit here for you. So the first ordered pair is 0, 1, which is your critical point. Then our next ordered pair is 1, 2, over 1 up 2. Then the next ordered pair over 2 up 4. And then 3, 8, over 3 up 8. And then we go backwards, negative 1/2, 1/2. Negative 2, 1/4. Negative 3, 1/8. And then we just connect the dots and graph this function. So this is an exponential function of y equals 2 to the x. If you like it as f of x notation, it's just f of x equals 2 to the x. And that's how you graph your function. All right, so let's talk about some important pieces of this graph, the domain. What type of numbers can you plug in? Well, notice here, these are all real numbers that you can plug in. Any number can work. So the domain is, for this exponential function, is all real numbers. The range. Remember, the range focuses on the y values. What do you get out? Well, there tends to be no negative y values. So I'm putting a horizontal line here at y equals 0. So everything happens above this line, this horizontal line, y equals 0. So this is called a horizontal asymptote. So the range is going to be y greater than 0. So then asymptotes, you have an asymptote then at y equals 0. X-intercepts. Are there any x-intercepts? Does anything touch along the x-axis here? No. Nothing is going to be able to touch. And then on the y-axis, you have a y-intercept right here of over 0 up 1, which also is your critical point. Notice that this graph is continuous, yes. It doesn't like stop and then start back up again. And it's increasing over time. I erase this here. When I move left to right, going from left to right, the numbers are getting bigger. So yes, this is an increasing function. We'll talk later about a graph is a decreasing function.